According to the National Electrical Code, specifically regarding kitchen electrical safety, all electrical outlets within 6 feet of a sink are required to have ground fault circuit interrupters. This GFCI protection extends to outlets on countertops, backsplashes, and islands. Therefore, a stove outlet within that 6-foot radius needs GFCI protection. A ground fault circuit interrupter is a safety device designed to protect individuals from electrical shock. It works by monitoring the electrical current flowing through a circuit. If the GFCI detects that current is leaking to ground, indicating a potential ground fault, it quickly trips and cuts off the power to the circuit. This interruption of power happens very rapidly, typically within a fraction of a second, which is fast enough to prevent serious injury or electrocution. A ground fault occurs when electrical current deviates from its intended path and instead flows through an unintended path to ground. This can happen when the insulation on a wire is damaged, allowing the current to come into contact with a grounded surface. It can also occur when a person comes into contact with a live wire while simultaneously touching a grounded object. In such cases, the person becomes part of the ground fault path, and the electrical current flows through their body. This is what causes electric shock. The GFCI is designed to detect these ground faults and interrupt the circuit before a dangerous amount of current can flow through a person's body. A GFCI outlet has 2 slots for plugging in electrical devices, just like a standard outlet, but it also has 2 test buttons labeled Test and Reset. The test button is used to verify that the GFCI is functioning correctly. When the test button is pressed, it simulates a ground fault, which should cause the GFCI to trip and cut off power to the outlet. If the GFCI does not trip when the test button is pressed, it means that the device is not working properly and needs to be replaced. The reset button is used to restore power to the outlet after the GFCI has tripped. When a ground fault is detected and the GFCI trips, the reset button will pop out. To restore power, simply press the reset button back in. If the GFCI trips repeatedly, it indicates that there is a persistent ground fault on the circuit, and a qualified electrician should be called to investigate and repair the problem. It's important to understand the difference between a GFCI and a standard circuit breaker. While both devices are designed to protect against electrical hazards, they do so in different ways. A standard circuit breaker is designed to protect against overloads and short circuits. An overload occurs when too much current is flowing through a circuit, typically due to too many devices being plugged into the circuit at the same time. A short circuit occurs when there is a direct connection between 2 wires with different voltages, bypassing the normal circuit path. In both cases, the circuit breaker trips and cuts off power to the circuit to prevent overheating and potential fire. A GFCI, on the other hand, is specifically designed to protect against ground faults. It monitors the current balance between the hot and neutral wires in a circuit. If there is a difference of even a few milliamps, indicating a current leakage to ground, the GFCI will trip. This is much more sensitive than a standard circuit breaker, which typically requires a current imbalance of several amps to trip. Therefore, a GFCI provides a much higher level of protection against electric shock than a standard circuit breaker. The National Electrical Code has specific requirements for GFCI protection in various locations, particularly in areas where there is a high risk of electric shock, such as kitchens, bathrooms, and outdoor areas. In kitchens, GFCI protection is required for all outlets serving countertop surfaces, as well as outlets within 6 feet of a sink. This is because the presence of water and conductive surfaces in these areas increases the risk of ground faults and electric shock. The requirement for GFCI protection within 6 feet of a sink means that even if the stove outlet is not directly above the countertop, it still needs a GFCI if it is within that zone. The NEC mandates GFCI protection in these areas due to several factors. Firstly, water is an excellent conductor of electricity. The proximity of sinks and countertops to electrical outlets increases the likelihood of water coming into contact with electrical devices or wiring, creating a path for current to flow to ground. Secondly, kitchen appliances, such as toasters, blenders, and coffee makers, often have metal housings. If the insulation on the internal wiring of these appliances is damaged, the metal housing can become energized, creating a shock hazard. Thirdly, people often have wet hands when working in the kitchen. Wet skin significantly reduces the body's resistance to electrical current, making it easier for current to flow through the body in the event of a ground fault. Installing a GFCI outlet is a relatively straightforward process, but it should only be done by a qualified electrician. The installation involves connecting the hot, neutral, and ground wires to the appropriate terminals on the GFCI outlet. It's important to ensure that the wiring is done correctly and that the GFCI outlet is properly grounded. Incorrect wiring can render the GFCI ineffective or even create a safety hazard. In some cases, it may be possible to protect an entire circuit with a single GFCI circuit breaker installed in the electrical panel. This type of GFCI breaker provides the same level of protection as a GFCI outlet, but it protects all of the outlets in the circuit. This can be a more cost-effective solution if multiple outlets on the same circuit require GFCI protection. When replacing an existing outlet with a GFCI outlet, it's important to identify the load and line wires. The line wires are the wires that bring power to the outlet from the electrical panel, while the load wires are the wires that carry power from the outlet to other devices or outlets down the line. The GFCI outlet has separate terminals for the line and load wires, and it's crucial to connect the wires to the correct terminals. Connecting the wires incorrectly can damage the GFCI outlet or cause it to malfunction. It is also important to regularly test GFCI outlets to ensure that they are functioning properly. The test button should be pressed at least once a month to verify that the GFCI is tripping and cutting off power to the outlet. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. GFCIs have a limited lifespan and may eventually fail due to age or wear and tear. Replacing a GFCI outlet is a simple and inexpensive way to ensure continued protection against electric shock. It is essential to use the correct type of GFCI outlet for the application. There are different types of GFCI outlets designed for different purposes. For example, some GFCI outlets are designed for use in wet locations, such as bathrooms and outdoor areas. These outlets have a weatherproof cover that protects the outlet from moisture. Other GFCI outlets are designed for use with specific types of appliances, such as hot tubs and swimming pools. These outlets have additional features that provide enhanced protection against electric shock. When choosing a GFCI outlet, it's important to consider the specific requirements of the application and select an outlet that is designed for that purpose. It is vital to remember that GFCI protection is not a substitute for safe electrical practices. Even with GFCI protection, it's still important to avoid contact with electrical devices and wiring when your hands are wet, and to never overload electrical circuits. Following safe electrical practices is the best way to prevent electric shock and other electrical hazards. When working with electricity, always turn off the power at the circuit breaker before touching any wires or components. Use insulated tools and wear rubber gloves to protect yourself from electric shock. If you are not comfortable working with electricity, it's best to call a qualified electrician to do the work for you. Electrical work can be dangerous, and it's important to take the necessary precautions to protect yourself from injury. The National Electrical Code is updated every 3 years, so it's important to stay up to date on the latest requirements for GFCI protection. Local building codes may also have additional requirements, so it's important to check with your local building department before starting any electrical work. By following the National Electrical Code and local building codes, you can ensure that your electrical system is safe and up to code. GFCI protection is an important safety feature that can help to prevent electric shock. By understanding how GFCIs work and where they are required, you can take steps to protect yourself and your family from electrical hazards. The kitchen is often considered the heart of the home, but it can also be a hazardous area due to the presence of water and electricity. By installing GFCI protection in your kitchen, you can significantly reduce the risk of electric shock and make your kitchen a safer place for everyone. Remember, the 6-foot measurement is a radius extending from the sink. Any part of the outlet within that radius requires GFCI protection. Always consult the latest edition of the National Electrical Code and local amendments for the most accurate and up-to-date information. The NEC is a comprehensive set of guidelines and regulations designed to ensure the safety of electrical installations. Adherence to the NEC is crucial for protecting people and property from electrical hazards. Consider the specific situation of the stove outlet. If the stove is a freestanding unit and the outlet is behind it, but within 6 feet of the sink, it still requires GFCI protection. If the stove is built in and the outlet is directly behind it, accessing the outlet for testing and resetting the GFCI may be difficult. In such cases, a GFCI circuit breaker in the electrical panel might be a more practical solution. This allows for convenient testing and resetting of the GFCI without having to move the stove. The purpose of a GFCI is to detect small imbalances in current that indicate a leakage to ground. Standard circuit breakers are designed to protect against overloads and short circuits, which involve much larger current flows. A GFCI is far more sensitive and reacts much faster to ground faults, providing a critical layer of protection against electric shock. The rapid response of a GFCI is what makes it so effective at preventing serious injury. It can interrupt the flow of electricity in milliseconds, which is often faster than the time it takes for a person to react to an electric shock. This rapid interruption can significantly reduce the severity of the shock and prevent electrocution. In addition to protecting people from electric shock, GFCIs can also help to prevent electrical fires. Ground faults can generate heat, which can ignite nearby combustible materials. By interrupting the flow of electricity in the event of a ground fault, a GFCI can prevent this from happening. Proper grounding is also essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker or GFCI to trip and cut off power to the circuit. Without proper grounding, fault current can flow through unintended paths such as a person's body, causing electric shock. It is imperative to ensure that all electrical outlets and appliances are properly grounded. The grounding wire is typically a green or bare copper wire. It should be connected to the grounding terminal on the outlet and to the grounding bus bar in the electrical panel. If you are unsure whether your electrical system is properly grounded, consult a qualified electrician. Regular inspection of electrical cords and appliances is also important for preventing electrical hazards. Look for signs of damage such as frayed cords, cracked insulation, and loose connections. Damaged cords and appliances should be repaired or replaced immediately. Never use an appliance with a damaged cord. Overloading electrical outlets can also be dangerous. Avoid plugging too many appliances into a single outlet. This can cause the outlet to overheat and potentially start a fire. Use power strips with built-in circuit breakers to protect against overloads. Educating family members about electrical safety is also crucial. Teach children not to play with electrical outlets or appliances. Explain the dangers of electricity and the importance of following safe electrical practices. By taking these precautions, you can create a safer home environment for everyone. The information provided here is for general guidance only and should not be considered a substitute for professional advice from a qualified electrician. Always consult with a licensed electrician for any electrical work or concerns.